All right, let's take a look at speed versus velocity and what they both mean. So we know an object is in motion if we check its frame of reference to something else. If we can see that it's moving in comparison to something else, we know it's in motion. But now we need to find out how fast is it going. So we're going to be able to calculate speed. And speed is distance divided by time. So on your formula sheet, you're going to want to write that down. Speed equals distance divided by time. And I can rearrange that. I can do time is equal to distance divided by speed, or I could calculate distance, right? Distance then would be speed times time. Or on your handy dandy formula sheet, you can do a speed triangle, and I would recommend that you do that. In this case, we always take the two that are multiplied together, speed and time, and those go on the bottom. Speed and time, and speed, remember, is distance divided by time. Now, the difference is I don't have a unit to put in here because there is no standard unit of speed. We can have miles per hour, we can have kilometers per hour, we can have meters per minute, meters per second, centimeters per millennia, or centimeters per century. I mean, there's so many different variations of speed. It's just simply straight up distance divided by time. You want to add this into your formula sheet now. Pause the video if you need to, but make sure it gets in there. All right, so we can calculate the different ways to do that. Remember, when we're doing this, if I were to put my finger over that and I were to say I'm trying to find speed, I cover that up and I know speed is distance divided by time. If I want to find time, I cover up the time, it's distance divided by speed. And if I'm trying to find distance, I cover that up and it's speed next to t, so speed times time. So that, remember, is how we use our triangle. And we'll make that disappear so we can move on, otherwise it will just keep dragging over. The difference between speed and velocity is velocity actually includes direction. So when you know both the speed and the direction of an object's motion, you know the velocity. In this case, the space shuttle's velocity is however many kilometers per second up. Because I included the direction, it's no longer just a speed, it's a velocity. If I said the storm is coming at us from 20 miles per hour, that's a speed. If I said the speed is coming at us from the north at 20 miles per hour, that's a velocity. Air traffic controllers need to know velocity because they need to know not only how fast airplanes are going, but what direction they're heading in. You know, if I've got a plane going in this direction and this direction at the same level, and they're both going 500 miles per hour, it doesn't really matter. But if they're going this way, it matters. You know, we don't really want a mid-air collision. So velocity is simply speed with direction added. So to calculate speed, we talked about this with the triangle, but here's the formal one. And speed of an object is the distance the object travels in 1 unit of time. So speed of 2 centimeters per travel 2 centimeters in 1 second is read as 2 centimeters per second. Remember that handy dandy little line there is read as per. A duck waddles at 75 meters in 25 minutes. I have my distance, speed is distance divided by time, distance on top divided by my time on the bottom. I could reduce that down or divide 75 by 25 and I get 3 meters per second, read again as 3 meters per second. I could also probably more commonly write that as 3 meters backslash second. That's how we would actually write it on our math sheets. Another thing I want you to know is if you ever have to hand in work in science, you would actually put this: speed is equal to 75 meters over 25 minutes. And you're going to notice that minutes I do as MIN because M stands for meter, so we can't use M again for minutes because that would be meter divided by meter, and that M divided by M would just cancel and that doesn't work. And then you would write your answer as 3 meters per second. If I were to do this, and actually we were in class and we were all together, and we were doing this on paper instead of just notes, which we'll do later, I would expect to see this. In science, If you have the most perfect math, but you forget the number, I'm not giving you any credit for it. If you just gave me the answer is 3, I'm going to assume you mean 3 hockey pucks, or 3 haircuts, or 3 puppies, or 3 swans. But in science, this unit means as much or more as the number, because meters per second tells me that that is a speed unit. If you told me meters per second squared, I would be able to tell you that that's an acceleration unit. If you were to tell me it's 3 kilometers, I know that's a distance. So in science, the unit tells us everything. So on paper, when we go to do this, you need to tell me what it is we're solving for, in this case, speed. You need to set up your problem with units, and then you need to tell me what the answer is with units. If you miss the units at the end, you get nothing. If you forget this setup, you've already lost half of it, and that's assuming you have the units. So if you just said the answer is 3, you get 0 credit. I'm just warning you in advance. I'm really picky about this because it's important, because the farther we get into this physics portion, we're going to put a whole bunch of these equations together to get one thing. You might do 5 different things to get to the end product, and you're going to need to keep track of your units so that you know what we're talking about. So it's a good habit to get into now. Constant speed. If the speed of an object does not change, the object is traveling at a constant speed, and you know that its speed is the same at all times during its motion. Most things don't travel at a constant speed. When I drive into work, I start from a dead stop. My car is parked in the driveway. I have to back up, and then I have to slow down and come to a stop, and I have to put my car in forward and drive, and then I have to come to the end of my street and then turn, and then go to the end of that street and come to a stop and turn, and then I drive at, I accelerate until I get to 30 miles per hour, and then I drive that till I hit the next stop sign. So what I'm trying to say is, I don't travel 30 miles per hour to get to school. I don't travel 55 miles an hour the whole time on the freeway. First of all, 494 is 60 miles per hour, and 394 is 65, and then I go down to 60, and then I go down to 55, and then I go down to 45, and then I go down to 35. So you see what I'm saying? And then I have to go to 30. So I'm never traveling at a constant speed. But let's say a horse could travel at a constant speed, and for a brief period you can. If a horse travels 21 meters in 3 seconds, what's the horse constant speed for those 3 seconds? Well, I would set it up just as a speed problem. 21 meters divided by 3 seconds means its constant speed for those 3 seconds is 7 meters per second. That's a constant speed over that span of time. Average speed takes the total distance divided by the total time. So for example, my travel to work is my speed of travel. I could calculate. My total distance is 25 miles. And my time is generally 35 minutes. Now, to calculate that, if you can't do it in your head, and believe me when I tell you that it's too late at night for me to do that, take your handy dandy calculator, take 25 divided by 35, and my average speed is 0.71 miles per minute. That's my average speed. Okay, well that's less than a mile a minute, but you have to think about that. That's actually not too bad, because on 494, where I can go 60 miles per hour, I will travel a mile a minute. So anytime I have to slow down, it's going to be less than a mile a minute. So my average speed, even though I can go a mile a minute on the freeway, or on 394 just a little bit over a mile a minute, my average speed is the total distance divided by the total time, which is slightly less than a mile a minute. All right, so we've looked at speed, we've looked at constant speed, we've looked at average speed. Now we need to look at a graph. Now what people forget is graphs are actually division bars. Speed is distance divided by time. This is a speed graph. Distance is on the y-axis. Usually the numerator, the one on top, goes on the vertical, the y-axis. And your denominator, the one on the bottom, goes on the x-axis. So speed is distance divided by time. So if I go and look at 9:30, it's been traveling for 30 minutes and it traveled 40 kilometers. I could calculate its speed at that point. It would be 40 kilometers divided by 30 minutes, and I could calculate that out. Now, the fact that this is a straight line is probably saying this is traveling at a pretty constant speed, and we could calculate that out, which is what we're going to be doing on the next assignment when you do some speed problems. But you need to understand that you can also calculate speed simply by doing slope, rise over run. So I went up 40, I went across 30 minutes, so my speed would be distance divided by time, 40 kilometers divided by 30 minutes. If I went from 9 o'clock to 10 o'clock, well, that's actually easier to calculate, right? I have a rise of 80 and a rise of 80 and a run of an hour. So if I calculate kilometers per hour, that's 80 kilometers per 1 hour, which is 80 kilometers per hour. And I think you'll find that's a pretty constant speed because it's not changing. It's not getting steeper, it's not getting slower. So here's, remember, rise and my run. Here is from here to here, from 5 seconds to 15 seconds is 10 seconds. That's my run. And my rise goes from looks like about 15 to about 45, so a rise of 30, and I can calculate that as 30 divided by 10, or 3 meters per second. So speed versus time. This is getting a little ahead of ourselves because this is acceleration. This is an acceleration graph because look on the side, it's speed over time. So be careful when you're looking at graphs to figure out if it's distance divided by time, it's a speed graph. If it's speed divided by time, it's acceleration. I'm not going to get into that. I just want you to be careful when you're looking at graphs that actually does happen. So average speed, to find the average speed, their total distance was 32 kilometers in the first 2 hours and then 13 kilometers in the next hour. So my total distance is 32 plus 13, which is 45 kilometers, and 2 plus 1 hour is a total of 3 hours. So I set it up as average speed of 45 kilometers in 3 hours, or we traveled an average of 15 kilometers per hour. Velocity is important because we need to know sometimes not just how fast something's going, but which direction. Air traffic controllers, we talked about the fact, need to know if planes are heading in the same direction or away from each other to make sure they avoid air collisions. Meteorologists need to know which direction a storm is going to head so that they know who to warn. You know, if I have a tornado that is 100 miles south of me and heading south, I'm not worried. If it's a mile north of me heading south, I might need to worry. So meteorologists, air traffic controllers, I need to know velocity when I travel somewhere because I need to know which way to turn, and I need to know how fast I can go on that road. I need to go north on 494 at 60 miles per hour. That's a velocity. Traveling on 494 at 60 miles an hour, that's just a speed. So the next thing we're going to do is an item called Speedy Journey. That will be next on your list.